Have you noticed that the same amount of effort no longer produces the same result? A full night's sleep used to restore you completely. Now you wake up and the fatigue lingers. A busy day used to feel satisfying. Now it leaves you depleted for days afterward. This is not simply aging. This is a signal, one that most of us have never been taught to read. Beneath the surface of these subtle shifts lies a design, an architecture that has powered human life for hundreds of thousands of years. And somewhere along the way, most of us drifted from it. What you're about to understand is not a protocol or a program. It is a map of that original design, and a quiet explanation of why so many of us feel the distance between how we live and how we were built to function. You are listening to the Longevity Library, where we archive the wisdom of healthy aging. The architecture of vitality. Understanding the body's design for healthy aging. There comes a moment in midlife when the body begins to speak in a different voice. It is not a voice of alarm, necessarily, but one of subtle shifts, a little less resilience after a late night. A little more time needed to recover from exertion. A few extra pounds that seem determined to stay. For many, these changes arrive quietly, almost unnoticed, until one day they accumulate into a felt sense that something has fundamentally altered. This is not decline in any dramatic sense. It is simply the body revealing its design, showing us the systems that have been working silently for decades, and asking whether we might now pay them a different quality of attention. The question that arises in midlife is not how to stop time, but how to understand what the body needs to continue functioning well within time's steady movement. What follows is an exploration of that question, not a set of instructions, but a way of seeing the body's architecture, the systems that power it, and the patterns of living that either support or strain those systems. The goal is not eternal youth, which is neither possible nor perhaps even desirable. The goal is vitality, the capacity to live fully within whatever years we have, with energy that matches our intentions and bodies that cooperate with our days. The question of energy. Energy is the currency of life. Every thought, every movement, every cellular repair, every immune response requires it. Yet for much of life, we take energy for granted. It flows, and we spend it, rarely considering where it comes from or why it sometimes falters. The experience of normal fatigue is familiar to everyone. A long day of physical work, a demanding mental task, an emotionally intense experience, these leave us tired. And after rest, we are restored. This predictable pattern, in which effort is followed by recovery, is a sign of healthy function. Pathological fatigue operates differently. Its defining characteristic is not the tiredness itself, but the delay in recovery. When someone exerts themselves beyond a certain threshold, the consequences appear not immediately, but the following day, or sometimes several days later. A simple social engagement, a modest amount of physical activity, a mentally focused morning, all may exact a price that is paid later, with interest. This delayed fatigue pattern reveals something essential. The body's energy systems are not merely depleted, but compromised in their fundamental capacity to generate and deliver energy. Understanding why this happens requires looking beneath the surface of symptoms to the architecture that produces energy in the first place. The body as a system of systems. To understand energy, it helps to think of the body not as a single engine, but as an interconnected set of systems, each with its own role in the conversion of food and air into the vitality that powers life. The fuel system begins with food. What enters the digestive tract determines what becomes available to the rest of the body. But digestion is not simply about what we eat. It is about what we absorb, and what happens in the complex ecosystem of the gut before nutrients ever reach the bloodstream. The engine system operates within every cell. Microscopic structures called mitochondria serve as cellular power plants. converting fuel from food into the energy molecules that drive all cellular activity. Without well-functioning mitochondria, energy cannot be produced regardless of how much fuel is available. The control systems regulate how fast the engine runs. The thyroid gland produces hormones that set the metabolic pace, determining how rapidly cells convert fuel to energy. The adrenal glands produce hormones that allow the body to respond to stress, to gear up when demands increase, and to recover when challenges pass. When all these systems work in harmony, energy flows reliably. When any one system falters, the others must compensate. When multiple systems are compromised, the result is the delayed fatigue pattern that characterizes so much of chronic health struggle in midlife and beyond. The evolution of the human digestive system. The human digestive tract has a design that is unusual in the natural world. It combines features of two different digestive strategies, which together have allowed our species to thrive on an extraordinary variety of foods. The upper portion of the digestive system, the stomach and small intestine, is designed to function as a sterile, acidic environment dedicated to breaking down and absorbing animal products, meat, fat, and the proteins and fats that come from animal sources. In this respect, it resembles the digestive system of a carnivore. The lower portion, the large intestine or colon, is designed to function as a fermenting environment where plant fibers are broken down by beneficial bacteria. In this respect, it resembles the digestive system of a herbivore. This dual design is one of humanity's great evolutionary advantages. It allows us to extract nutrition from both animal and plant sources, to adapt to different environments and different food availabilities, to survive and thrive across diverse landscapes. But this sophisticated system depends on maintaining the right conditions in each compartment. The upper gut must remain relatively sterile, with bacteria confined largely to the lower gut where they belong. When bacteria and yeast establish themselves in the upper gut, the entire design is compromised. When fermentation moves upstream, the modern diet, particularly in industrialized societies, is characterized by high levels of sugar and refined carbohydrates. These substances do not require the same digestive processing as animal products or complex plant fibers. They are rapidly absorbed, and they create conditions in the upper gut that encourage microbial growth. When sugars and refined carbohydrates consistently overwhelm the upper digestive system, bacteria and yeast that should be confined to the large intestine migrate upward. They establish colonies in the small intestine, transforming a sterile digestive environment into a fermenting one. This shift from digestion to fermentation in the upper gut has consequences that ripple throughout the body. The microorganisms that colonize the upper gut produce metabolic byproducts as they ferment undigested carbohydrates. These include bacterial endotoxins and fungal mycotoxins, compounds that the body recognizes as foreign and toxic. They enter the portal circulation and travel directly to the liver, which must process and neutralize them before they can reach the general circulation. The energy cost of this detoxification is substantial. At rest, the liver consumes more energy than any other organ, approximately 27% of the body's resting energy expenditure, compared to 20% for the brain and 7% for the heart. When the liver must constantly process toxins from an overgrown upper gut, much of the body's available energy is diverted to this task, leaving less for other functions. The microorganisms in the upper gut also consume nutrients before the human host can absorb them. Vitamins, minerals, essential fatty acids, these are taken up by the bacteria and yeast that sit at the front of the digestive line. This explains why many individuals can take supplements and still show deficiencies. They are not absorbing the nutrients. Their gut microbes are. Some of these microorganisms also enter the bloodstream directly. This is not an unusual phenomenon. Dental bacteria routinely enter the circulation after toothbrushing, which is why individuals with certain heart conditions receive antibiotics before dental procedures. But when unfamiliar microbes from the upper gut continuously seed the bloodstream, the immune system takes notice. These microbes become lodged in various tissues, joints, skin, connective tissue, organs, and wherever they settle. Inflammation follows. The immune system attacks them as foreign, and the resulting inflammatory response can manifest as any number of conditions that are typically viewed as distinct diseases. Various forms of arthritis, skin conditions, inflammatory bowel disease, asthma, fibromyalgia, and others. What appears to be separate conditions may in fact share a common root in the microbial environment of the upper gut. The fuel that changes everything. If the upper gut has become a fermenting environment rather than a digestive one, the most direct intervention is to change what enters it. This is where dietary pattern becomes not merely a matter of nutrition, but of fundamental microbial ecology. The dietary approach that most directly addresses upper gut fermentation is one that eliminates the foods that feed microbial overgrowth while providing the nutrients that support human metabolism. This approach eliminates all grains, all dairy products, all sugars and sweeteners, all refined carbohydrates, and all processed foods. It includes meat, poultry, fish, eggs, non-starchy vegetables, and healthy fats. It restricts carbohydrates sufficiently to shift the body's primary fuel source from glucose to ketones. The rationale for this pattern rests on evolutionary history. For hundreds of thousands of years, this is what human beings ate. The grains and dairy products that form the foundation of modern industrial diets are recent arrivals in human experience, too recent for meaningful genetic adaptation. The human genome, the human digestive system, the human metabolic pathways, all evolved in the context of a diet that was essentially Paleolithic and, for much of human existence, often ketogenic. When carbohydrates are severely restricted, the body shifts from running on glucose to running on ketones. Ketones are molecules produced from fat that serve as an alternative fuel for most cells, including brain cells. Contrary to popular assumption, ketones are not an emergency backup fuel. They are the preferred fuel for mitochondrial function. Mitochondria operate more efficiently on ketones than on glucose. This shift has profound implications for energy stability. Glucose metabolism produces sharp peaks and valleys in blood sugar, with corresponding peaks and valleys in energy and mood. Ketone metabolism produces a steady, stable fuel supply that does not fluctuate with meals. Individuals who make this transition consistently report more stable energy, clearer thinking, and the disappearance of the mid-afternoon energy crash that has become normal in modern life. The transition period, however, can be challenging. Sugars and refined carbohydrates are physiologically addictive. They trigger dopamine release in brain reward centers similarly to other addictive substances. When consumption stops, withdrawal symptoms occur: headache, fatigue, irritability, mental fog. These symptoms typically resolve within days to a week, after which most individuals feel markedly improved. The longer an individual can maintain the pattern, the more complete the adaptation becomes. The goal is not perfection, but direction, moving consistently toward a pattern that supports rather than strains the body's energy systems. The cellular engines. Within every cell of the body, tiny structures called mitochondria serve as power plants. They take fuel from food and, through a complex series of chemical reactions, convert it into adenosine triphosphate, the molecule that stores and transfers energy within cells. Mitochondria are numerous. A single cell may contain hundreds or thousands of them, depending on the cell's energy demands. Heart muscle cells. which contract constantly, are densely packed with mitochondria. Fat cells, which store energy rather than using it, have far fewer. When mitochondria function well, energy flows. When they function poorly, energy falters regardless of how much fuel is available or how well the digestive system absorbs it. Research has identified several factors that commonly impair mitochondrial function in individuals with chronic fatigue. These include deficiencies in specific nutrients that mitochondria require for their work. Magnesium is essential for the final step in ADP production. Without adequate magnesium, the energy molecule cannot be formed. Vitamin B3, also known as niacin, is critical for the transfer of energy within the mitochondrial membrane. Zinc participates in numerous enzymatic reactions related to energy production. Coenzyme Q10 shuttles electrons through the mitochondrial electron transport chain. Without it, the entire process stalls. D-ribose provides the structural backbone of ADP itself. When these nutrients are deficient, supplementation often improves mitochondrial function and clinical symptoms. But nutrient deficiencies do not arise in isolation. They typically reflect either inadequate intake, poor absorption, or both, which returns the focus to digestive function and dietary pattern. Mitochondria can also be impaired by toxins that block their function. Various environmental chemicals, organophosphates and pesticides, heavy metals, certain industrial compounds, inhibit the mitochondrial enzymes responsible for energy production. This explains why individuals exposed to these substances often develop fatigue syndromes. Their mitochondria have been chemically poisoned. Identifying toxin exposures through careful history taking allows individuals to reduce their burden and support mitochondrial recovery. Common sources include pesticides on conventionally grown produce, heavy metals in contaminated water or certain fish, household chemicals in cleaning products, and ingredients in personal care products. The pace of life. If mitochondria are the engine, the thyroid gland is the accelerator pedal. Thyroid hormones set the pace at which cells operate, determining how rapidly mitochondria convert fuel to energy. When thyroid function is optimal, metabolic rate matches the body's needs. When thyroid function is low, everything slows down. Energy production decreases. Body temperature drops. Digestion slows. Mental processing becomes sluggish. The classic symptoms of hypothyroidism: fatigue, cold intolerance, weight gain, constipation, dry skin, hair loss, poor memory, reflect this generalized slowing of cellular activity. Conventional diagnosis of thyroid dysfunction relies heavily on blood testing, often focusing exclusively on thyroid-stimulating hormone. TSH is produced by the pituitary gland and signals the thyroid to produce more hormone. When TSH is elevated, it suggests the thyroid is not producing enough hormone, and the pituitary is trying to compensate. This approach captures only the most obvious cases of thyroid failure. It misses many cases where thyroid hormone levels are suboptimal for the individual, even though they fall within population reference ranges. Many experts in thyroid function estimate that a substantial portion of the population, perhaps up to 40%, may have some degree of thyroid hormone deficiency that affects their energy and health. The characteristic pattern of hypothyroidism includes multiple symptoms that cluster together. Fatigue that does not improve with sleep. Sensitivity to cold that others do not feel. Weight that accumulates despite reasonable effort. Constipation that becomes chronic. Skin that dries and hair that thins. Memory that feels less reliable than it once was. When several of these symptoms appear together, thyroid function deserves attention regardless of what blood tests show. Responding to stress. The adrenal glands produce hormones that allow the body to respond to stress. Cortisol, the primary stress hormone, mobilizes energy, focuses attention, and suppresses non-essential functions during challenges. It is part of the body's emergency response system, designed for short-term use, not chronic activation. When stress is occasional and recovery follows, adrenal function remains healthy. When stress becomes chronic and unrelenting, the adrenal response can become dysregulated. Cortisol may remain chronically elevated, producing anxiety, sleep disruption, and difficulty relaxing. Or cortisol may eventually drop, producing profound fatigue, low blood pressure, dizziness upon standing, and cravings for salt. This adrenal dysregulation is not a disease in the conventional sense. It is a physiological response to prolonged demand without adequate recovery. The body was designed for a pattern of life that included periods of intense activity followed by periods of rest. Modern life often reverses this pattern: chronic low-grade stress without the intense activity, and inadequate rest to allow recovery. Supporting adrenal function begins with addressing the foundations: adequate sleep, proper nutrition, and intentional stress management. The body cannot recover from stress if it never rests. Sleep is not optional for adrenal health. It is the primary period of repair and restoration. Specific nutrients support adrenal hormone production. Vitamin C is concentrated in adrenal tissue and is used in the synthesis of cortisol. Pantothenic acid, also known as vitamin B5, is similarly essential for adrenal function. Magnesium and zinc participate in numerous reactions related to stress response. The inflammation connection. Some individuals with chronic fatigue have an additional component: persistent inflammation. Their energy systems are compromised, and their immune systems remain chronically activated, producing low-grade inflammation throughout the body. This inflammatory state, sometimes termed myalgic encephalomyelitis, represents a distinct pattern. The immune system has mobilized and never fully stood down. It remains in a state of alert, consuming energy and producing inflammatory molecules that affect every tissue. The immune system can be thought of as the body's standing army. Ideally, it mobilizes rapidly when a threat appears, deals with the threat efficiently, and then returns to a resting state. In the inflammatory pattern, the army mobilizes but never receives the signal to stand down. It remains on permanent alert, consuming resources and occasionally firing on non-threats. This chronic activation can arise from several sources. Persistent infection is one possibility. Sometimes the immune system remains activated because it has not successfully eliminated an infecting organism. The infection continues to replicate. The immune system continues to respond, and neither side achieves victory. This stalemate produces ongoing inflammation. Allergy represents immune error, attacking substances that pose no genuine threat. Food allergens, pollen, dust mites, and other environmental substances trigger immune responses that should be reserved for genuine pathogens. The army attacks tourists instead of invaders. Autoimmunity represents the most serious error: civil war, in which the immune system attacks the body's own tissues. The thyroid, the gut lining, the joints, the connective tissue. Any tissue can become a target. Autoimmune conditions affect approximately 5% of the population, and rates are increasing. Several factors have been linked to rising autoimmune rates. Vaccination, which is designed to provoke strong immune responses, can in susceptible individuals trigger immune activation that spills over into self-attack. Environmental toxins can similarly dysregulate immune function. Chronic infection can prime the immune system for overresponse. The modern environment presents multiple challenges to immune regulation. The question of childhood illness. An evolutionary perspective on immune function raises questions about modern approaches to childhood infections. Throughout human history, children experienced acute febrile illnesses, measles, mumps, chickenpox, and others as a normal part of development. These infections served a purpose. They trained the immune system. When a child encounters a virus and successfully clears it, the immune system learns. It develops memory cells that recognize that virus and respond more rapidly upon future exposure. It practices the complex dance of inflammation and resolution. It calibrates its responses based on real-world challenges. Children who experience these illnesses in the context of good nutrition, adequate vitamin D, vitamin C, zinc, and other immune-supporting nutrients typically recover fully and develop robust immune function. Epidemiological evidence has linked childhood infections with lower rates of certain cancers in adulthood, suggesting that immune training early in life has long-term protective effects. The modern approach of preventing all childhood infections through vaccination represents a different strategy. Vaccines are designed to provoke immune responses without causing illness, and they achieve this goal for many infections. But they do not perfectly replicate the experience of natural infection, and they may not provide the same breadth of immune training. The question of whether to vaccinate is complex and personal, involving considerations beyond the scope of this discussion. What is clear is that a fully functional immune system, supported by good nutrition and general health, can handle childhood challenges effectively. The focus on preventing every possible infection may reflect a misunderstanding of the immune system's need for appropriate challenge during its developmental years. The pattern of addictive eating. One of the most challenging aspects of dietary change is the addictive nature of sugars and refined carbohydrates. These substances activate brain reward pathways similarly to other addictive substances, creating cravings that can override conscious intention. The addictive pattern is visible in the typical daily rhythm of modern eating. Breakfast of fruit juice, cereal, and toast sends blood sugar soaring. Insulin floods the system to bring it down, driving sugar into fat cells. Blood sugar crashes. The brain perceives an energy crisis. Adrenaline surges to raise it again. Adrenaline creates anxiety, stress, and eventually disrupts sleep. By mid-morning, energy crashes again, prompting another sugar or caffeine fix. The cycle repeats throughout the day. This pattern is not a matter of weak will. It is a physiological addiction, reinforced at every turn by the body's responses. Breaking it requires recognizing it as addiction and approaching it as such. The transition period, when sugars and refined carbohydrates are withdrawn, produces predictable symptoms: headache, fatigue, irritability, mental fog. These are withdrawal, not signs that the diet is wrong. They typically resolve within days to a week, after which the body begins to adapt to running on ketones. Artificial sweeteners do not solve the problem. When the mouth tastes sweetness, the body anticipates a sugar rush and releases insulin in preparation. This maintains the metabolic roller coaster even without actual sugar consumption. Sweetness itself, regardless of source, perpetuates the addictive pattern. The goal is not permanent abstinence from all sweetness or all pleasurable foods. It is to break the addictive cycle so that these foods can be consumed occasionally, as flavor enhancers for special occasions, without triggering the compulsive pattern. Addiction makes foods bad masters. Breaking addiction allows them to become good servants. Practical approaches to change. Changing lifelong eating patterns is difficult, and acknowledging that difficulty is essential to success. The following approaches have helped many individuals navigate the transition. Start with education. Understanding why the change matters, the mechanisms of upper gut fermentation, the role of mitochondria. The pattern of addictive eating provides motivation that mere rules cannot sustain. When the body complains during withdrawal, knowledge of what is happening and why provides reason to persist. Prepare for withdrawal. The first several days of very low carbohydrate eating will likely be uncomfortable. Having realistic expectations reduces the likelihood of abandoning the effort when discomfort appears. Knowing that the discomfort is temporary and will resolve makes it easier to endure. Eliminate completely rather than reducing gradually. For addictive substances, gradual reduction often prolongs withdrawal and increases the chance of relapse. Complete elimination allows the body to adapt more quickly and reduces the constant negotiation with cravings. Find satisfying alternatives. Fat provides satiety in a way that carbohydrates do not. Meals rich in healthy fats, animal fats, olive oil, coconut oil, avocados, produce lasting fullness that reduces the urge to snack. Protein similarly satisfies hunger more effectively than carbohydrates. Plan for social situations. Eating differently from others creates social challenges that must be anticipated and managed. Eating beforehand. Bringing food to share. Choosing restaurants with adaptable menus. These strategies reduce the likelihood of being caught unprepared in situations where appropriate food is not available. Be patient with the body. Adaptation takes time. Mitochondrial function improves gradually. Gut microbial populations shift slowly. Thyroid and adrenal function may take months to normalize. The goal is long-term direction, not immediate perfection. The integration of systems. The body's energy systems do not operate in isolation. They form an integrated whole in which each component affects all others. Diet affects gut microbial ecology, which affects nutrient absorption and toxin production, which affects mitochondrial function, which affects energy availability, which affects thyroid and adrenal function, which affects how the body responds to stress, which affects immune function, which affects inflammation, which affects everything. This integration means that improvement in any area tends to support improvement in others. Better diet reduces gut fermentation, which reduces liver toxin load, which frees energy for mitochondrial function, which supports thyroid and adrenal recovery, which improves stress response, which reduces inflammation, which further supports energy production. The converse is also true. Deterioration in any area tends to pull others down with it. This is why chronic health problems often worsen gradually over time, then seem to accelerate as multiple systems become compromised. The implication for intervention is that the most effective approach addresses the foundations first. Diet is foundational because it affects everything else. Without dietary change, other interventions may provide temporary relief but cannot produce lasting improvement. With dietary change, other interventions become more effective and may eventually become unnecessary. The preventive perspective. The same principles that restore energy in chronic fatigue also apply to preventing the diseases of aging. Heart disease, cancer, dementia, autoimmune conditions all have been linked to the same underlying factors. Poor diet, gut dysfunction, mitochondrial impairment, chronic inflammation. Dementia is increasingly understood as a metabolic condition, sometimes called type 3 diabetes. The brain, like other organs, requires stable fuel supply and functional mitochondria. When blood sugar fluctuates wildly, when mitochondria function poorly, when inflammation damages neural tissue, cognitive function declines. The same dietary pattern that stabilizes energy also supports brain health. Heart disease has clear links to inflammation and oxidative stress. The same gut-derived toxins that burden the liver also damage arterial walls. The same insulin surges that drive fat storage also promote arterial plaque formation. The same inflammatory patterns that affect joints also affect blood vessels. Cancer metabolism research increasingly focuses on mitochondrial function. Many cancer cells have defective mitochondria and rely on alternative energy pathways. Supporting mitochondrial health may reduce the conditions in which cancer can thrive. Autoimmune conditions, as noted, are increasing rapidly. The same factors that dysregulate immune function, gut dysbiosis, toxin exposure, chronic infection, vaccination, may all contribute to rising rates. Addressing these factors early may reduce autoimmune risk. The preventive perspective recognizes that waiting for disease to develop before addressing these principles is unnecessary. The same approaches that treat established problems also prevent them from developing in the first place. The environmental dimension. Human health cannot be separated from environmental health. The same principles that support individual well-being, clean food, clean water, minimal toxins, support planetary well-being. This connection, sometimes called ecological medicine, recognizes that we are not separate from our environment but embedded within it. Pesticides that contaminate food and water also contaminate human tissues. Industrial chemicals that pollute air and soil also accumulate in human fat. Antibiotics that enter water systems through agricultural runoff also affect human gut microbiomes. The boundary between environmental and human health is largely artificial. Reducing personal toxic burden benefits both the individual and the environment. Choosing organic food when possible reduces pesticide exposure and supports farming practices that protect soil and water. Using simpler cleaning and personal care products reduces chemical exposure and reduces environmental contamination. Supporting policies that limit industrial pollution protects everyone. The connection runs deeper than individual action. The same industrial systems that produce cheap, processed food also produce environmental degradation. The same economic pressures that drive intensive agriculture also drive antibiotic overuse and soil depletion. Personal health choices and environmental concerns often align, pointing toward the same solutions. The role of knowledge. Conventional medical education, for all its strengths, provides limited training in the kind of root cause analysis required for managing complex chronic conditions. Most physicians receive minimal instruction in nutrition, mitochondrial function, environmental medicine, or the systems thinking that connects these domains. This is not a criticism of individual physicians, who work within systems that constrain what they can learn and practice. It is an observation about the structure of medical education and practice, which has evolved in a particular direction toward acute care, toward pharmaceutical intervention, toward specialization rather than integration. For individuals with chronic health problems, this means that self-education is not optional. It is essential. The resources exist: books, workshops, online information, practitioners who have pursued additional training in functional or ecological medicine, learning to ask why symptoms occur, what mechanisms drive them, and what interventions might reverse them is the path to improvement. This self-education is not a rejection of medical care. It is a complement to it, a way of becoming an informed partner in one's own health. The individual who understands their own body, who recognizes patterns, who knows which interventions help and which harm, becomes the expert on their own health. This knowledge cannot be outsourced. Learning in community settings offers advantages over solo study. In group workshops, individuals discover they are not alone. Others have similar symptoms, similar questions, and benefit from similar answers. Repetition reinforces learning. Working through specific problems together accelerates progress for everyone. The calm middle path. The approach outlined here is neither dramatic nor extreme. It does not promise miracles or demand perfection. It simply asks that we consider the body's design, the systems that power it, and the patterns of living that either support or strain those systems. The body was designed for movement, for varied whole foods, for periods of activity followed by periods of rest, for challenge followed by recovery. Modern life often inverts these patterns. Sedentary, eating processed foods, constantly stressed without the intense activity that stress responses were designed for, never fully recovering. Reversing these patterns does not require heroic effort. It requires consistent direction, small choices repeated daily that gradually shift the body's trajectory. A walk after meals instead of sitting. One meal at a time that follows the pattern that supports rather than strains. A few minutes of intentional stillness in a day otherwise filled with stimulation. Sleep prioritized as the foundation it is. The results of these small choices accumulate. Over weeks and months, energy stabilizes. Over years, disease risk decreases. Over decades, the body ages not with accelerating decline, but with gradual, graceful change. This is not the fountain of youth. It is something more realistic and perhaps more valuable. The capacity to live fully within whatever years we have, with bodies that cooperate with our intentions rather than opposing them. It is vitality, not immortality. And for those who seek it, the path is available, built from choices made daily, guided by understanding of the architecture that has supported human life for hundreds of thousands of years. A final reflection. There is a certain humility that comes with age, a recognition that the body has its own wisdom that we ignore at our peril. The symptoms that arise in midlife and beyond are not enemies to be suppressed, but messages to be understood. They tell us where our systems are straining, where our patterns are misaligned, where we have drifted from the design that supports healthy function. Listening to these messages does not require fear or alarm. It requires attention, curiosity, and the willingness to adjust course. The body speaks not in ultimatums, but in whispers, gradually increasing in volume if ignored. Those who learn to hear the whispers early can make small corrections before large problems develop. The principles outlined here are not new. They are ancient, encoded in the design of the human body over hundreds of thousands of years of evolution. They have simply been obscured by the novelty of modern life, by foods that did not exist until recently, by chemicals that never appeared in nature, by patterns of living that invert the rhythms for which we were designed. Recovering these principles is not a return to the past, but an integration of ancient design with modern knowledge. We understand more than our ancestors did about mitochondria and microbiomes, about hormones and inflammation. This understanding can guide us in applying timeless principles to contemporary life. The result, for those who make the journey, is not perfection but improvement. Better energy, clearer thinking, more stable mood, reduced disease risk, greater capacity to engage with life. These are not small things. They are the foundations of a life fully lived, in whatever years remain. And that, perhaps, is the deepest purpose of understanding the body's design. Not to extend life indefinitely, but to live the life we have as fully as possible, with vitality that matches our intentions and bodies that support our days. The body was never designed for perpetual youth. It was designed for something more attainable and perhaps more valuable. The capacity to live fully within whatever years we have, with energy that matches our intentions and systems that cooperate rather than resist. The question is not whether we can stop time, but whether we can align our lives more closely with the design that has supported human vitality for hundreds of thousands of years. If this exploration has sparked a question, a reflection, or simply a quiet recognition, we invite you to share your thoughts in the comments. And if you would like to continue this journey through the archives, we invite you to explore other videos in the Longevity Library and to subscribe so that new wisdom finds its way to you. This is the Longevity Library. Listen, learn, and live longer.